वेलकम यू ऑल। आज का लेक्चर हम वर्क पावर एनर्जी से ही करेंगे, लेकिन आज हम थोड़ा शॉर्ट आंसर्स 3 करने वाले हैं जो वर्क पावर एनर्जी में इंपॉर्टेंट क्वेश्चंस है। एक डेरिवेशन फॉर काइनेटिक एनर्जी और दूसरा है कि रिलेशनशिप बिटवीन काइनेटिक एनर्जी एंड लीनियर मोमेंटम और पावर इज इक्वल टू डॉट प्रोडक्ट ऑफ फोर्स एंड वेलोसिटी। ये 3 क्वेश्चंस हैं, इंपॉर्टेंट है तीनों, तो एक एक करके हम इनको सॉल्व करने वाले हैं। तो हमने लास्ट लेक्चर में वर्क एनर्जी थ्योरम सॉल्व की फॉर अ वेरिएबल फोर्स। हम कांस्टेंट फोर्स के लिए सॉल्व कर सकते हैं। लाइक उसके लिए क्या है कि सपोज अगर एक बॉडी है ऑफ मास m और हम इसे अप्लाई फोर्स करते हैं, ऑब्वियसली इसकी इनिशियल वेलोसिटी होगी या ये u होगा इनिशियल वेलोसिटी, और इनिशियली ये रेस्ट में भी हो सकता है, u कैन बी 0। हम सिर्फ जनरल इसको स्टेटमेंट में लिखेंगे कि दैट इनिशियली द वेलोसिटी इज u एंड आफ्टर सम फोर्स इज अप्लाइड its velocity changed to v. So there is change in velocity from u to v, and work energy theorem for constant force हम कैसे लिखते हैं? We know that there is a variation in the velocity and there is also a displacement s. This variation or change in velocity causes an acceleration that is related or that is given by a one-dimensional formula. V square minus u square is equal to 2as. Since there is acceleration, so there is applied force F. We can write A is equal to F over m. As you know from Newton's second law, force is equal to mass into acceleration, or acceleration is equal to F by m. So we substitute this second and first, we get V square minus u square is equal to 2F by m into s. By simplifying, m यहाँ पे ले जाएंगे, v square minus u square is equal to f into s, और ये 2 1 by यहाँ रहेगा। So f dot s is equal to 1 by 2 m v square minus 1 by 2 m u square. So this f into s gives you a work done, and this is equal to final kinetic energy because object is here with a velocity v. This is final kinetic energy minus this is initial kinetic energy. So change in kinetic energy is the work done. So I get the relation work done is equal to 1 by 2 m v square minus 1 by 2 m u square if initially object is at rest. If initially object is at rest, then u is equal to 0. So आप यहाँ substitute u 0 करें, you get work done is equal to 1 by 2 mv square. This work done is called kinetic energy. So kinetic energy is the energy possessed by the body due to its motion or due to its change of this speed. So the derivation for the kinetic energy is kinetic energy, work done is actually a kinetic energy, and kinetic energy is defined as 1 by 2 mv square, or is defined as the energy possessed by the body due to its motion. और ये है kinetic energy का. So suppose there are conditions here. अगर आपका so you have if u is equal to 0, your work done is equal to 1 by 2 mv square. You get expression for kinetic energy. So kinetic energy is equal to 1 by 2 mv square. स्टेट मैंने अभी बताई आपको. If u is greater than v, अगर इनिशियल वेलोसिटी ग्रेटर देन v है, यानी कि पहले स्पीड ज्यादा है उसके बाद कम हो गई है, तो वर्क डन इज नेगेटिव. तो फिर वर्क डन होगा इज लेस देन 0, वर्क डन इज नेगेटिव. If u is less than v, if initial velocity is less than final velocity ज्यादा है, initially object with low 0 speed थी या 0 velocity थी, फिर velocity change होके 12 हो गई या 15 हो गई या 20 हो गई, तो final velocity is greater than initial velocity, then work done is positive. Then work done is greater than 0, that is work done is positive. ये objectives हो सकते हैं. That condition for if initial velocity is greater than final velocity, work done is negative. If initial velocity is less than Final velocity work done is positive. If initial is 0, then kinetic work done is equal to 1 by 2 mE square is an expression for kinetic energy, and we have already stated the definition for the kinetic energy. Similarly, we calculated that F dot S is equal to 1 by 2 mv square minus 1 by 2 mu square. We just calculated in previous equation. I can write F is equal to 1 by 2 mv square minus 1 by 2 mu square divided by S. Or this is final kinetic energy minus initial kinetic energy divided by S. This is the relationship between the force and change in kinetic energy. The relationship between force and change in kinetic energy with respect to displacement, with respect to distance. कभी आ सकता है ये 2 मार्क्स का कि draw the relationship between force and change in kinetic energy. You can write like this. इसके बाद we have another short answer question, like we prove that kinetic energy is equal to 1 by 2 mv square. So let us denote this kinetic energy is denoted by E. So E is actually kinetic energy. We have designated it with E is equal to 1 by 2 mv square. Now we derive the relationship between linear momentum and kinetic energy. Linear momentum and kinetic energy. इसमें बहुत सारी न्यूमेरिकल्स आती है. खास ख्याल रखें, यहाँ पे न्यूमेरिकल्स बहुत सारे एग्जाम्स में आते हैं इस पे कि linear momentum and kinetic energy that में relation क्या है. You know linear momentum is denoted by P and linear momentum is equal to mass into velocity. यहाँ पे पहले से ही पता है कि linear momentum is denoted by P. It is the product of mass and velocity, and here we write kinetic energy E is equal to 1 by 2. यहाँ पे मल्टीपल m करूँगा न्यूमिनेटर में भी और डिनोमिनेटर में भी. यहाँ अपना है mv स्क्वायर. I multiply this numerator and denominator by m. ऊपर पहले से ही m है, it becomes m square and v square divided by m. So E is equal to, this becomes mv whole square divided by 2m. You know P is equal to m into v. Instead of this mv, I write P. So E is equal to P square by 2m. This is the relationship between kinetic energy and linear momentum. I can write it further. P square is equal to 2me, where E is kinetic energy, don't forget it. So P is equal to under root of 2me. ये बहुत सारे जगहों पे आपको इस्तेमाल हो जाएगा. Linear momentum is related to kinetic energy. This चाहे आप काइनेटिक थ्योरी आप गैसेस में जाएं या कहीं भी गैस मॉलिक्यूल की जो जहाँ पे एक्सक्लूसिवली एनर्जी जो होगी वो काइनेटिक होगी, तो वहाँ पे आप मोमेंटम ऐसे निकाल सकते हो. नोइंग द वैल्यू ऑफ द मास ऑफ द पार्टिकल, नोइंग द वैल्यू ऑफ द काइनेटिक एनर्जी, एंड यू कैन कैलकुलेट द लीनियर मोमेंटम. सो दिस इज द रिलेशनशिप बिटवीन लीनियर मोमेंटम P एंड काइनेटिक एनर्जी. इसके बाद आगे 3 क्वेश्चन अब तक. एक डेरिवेशन फॉर द, एक तो कांस्टेंट फोर्स के लिए वर्क एनर्जी थ्योरम, वहाँ से हमने इनिशियली ऑब्जेक्ट को जीरो वेलोसिटी दी तो वी गेट द डेरिवेशन फॉर काइनेटिक एनर्जी. फिर हमने कंडीशन ले ली इफ u इज ग्रेटर देन v एंड u इज लेस देन v, तो उसके लिए कंडीशंस. फिर हमने रिलेशनशिप बिटवीन फोर्स एंड चेंज इन काइनेटिक एनर्जी के दरमियान लिया. उसके बाद रिलेशनशिप बिटवीन मोमेंटम, लिनियर मोमेंटम एंड काइनेटिक एनर्जी का. इसके बाद हमें पता है कि सब पावर है. पावर is rate of work done, this dw by dt. You know the power is rate of doing work or the rate at which work is done. So dw by dt, or you can write power is equal to limit delta t tends to 0 dw over dt is called instantaneous power. The equation for instantaneous power. And you know its unit is watt, and another unit is commercial unit किलोवाट आवर. और कभी आपको वो एक पॉइंट का भी आ सकता है कि किलोवाट आवर कितना होता है, उसका वैल्यू कितना होता है, हाउ कैन दैट बी कन्वर्टेड टू जूल, वो भी आप ध्यान रखिए उसका भी. फिलहाल हम सिर्फ एक क्वेश्चन यहाँ निकालने वाले रिलेशनशिप बिटवीन पावर और द पावर इज द डॉट प्रोडक्ट ऑफ फोर्स एंड वेलोसिटी. शो दैट P is equal to F dot V. हम ये सॉल्व करने वाले हैं, ये बहुत बार कहा गया है अब तक. So we write P is equal to dWd. So this dW is a small work done. So I can write dW is equal to small force applied for a small displacement dx. If small displacement is produced by applying a force F, then you have small work done dW. So I can write this second will be substituted first, and I get P is equal to F dot dx divided by dt. You know that work done is a dot product of force and displacement. You have to take into consideration the angle between the applied force and the direction of displacement. So I write in F dot dx. So I know P is equal to this dx by dt. You know the change in displacement per unit time is known as velocity. So you get F dot v. This is the relationship between power and this. This is a relationship between this dot product between the force and velocity gives the power. This is how you can write. One definition is to write down the power in terms of directly the work done per unit time, and another is to write down the power in terms of force, dot product of force and velocity. These are 3-4 short answer questions that you can quickly solve in your exam to save your time. Thank you very much.